Hello, I'm Robert Toomey, a research developer at the newly renamed Cooperative Institute for Severe and High Impact Weather Research and Operations. I'm not going to try to pronounce that acronym just yet. This is a technical update to some of the changes added to the RAPIO project lately. There have been quite a few, but the main one is probably the addition of multi-directional algorithms. I'll briefly give a couple slides to define this a bit, and then I'll showcase an example. So two quick definitions. I'll call them non-interactive versus interactive algorithms for lack of better wording. Typically, with one of our MRMS or HMN algorithms, we tend to give the algorithm parameters a single time at startup. Then we trigger this algorithm in various ways. Either we cron fire it once so often, or we have a listing daemon that is triggered on new incoming data, say using the Linux iNotify system. The key thing to note here is that the user interaction is very limited, if any. And what I mean by that is that algorithms use their parameters once. Algorithms can use the data or check a file to change some, but it's very rare in our current usage. For example, in RAPIO, I do allow the logging mode from verbose to debug, for instance, to change in real time based upon a watch configuration file. The other type would be an interactive data algorithm. The idea here is that data processing depends more upon user interaction or on-demand requesting. It's less of a pipeline design. So imagine GUIs in general, such as AWIPS2, WG, ArcGIS, WG2. You're constantly telling the software how to filter and process your data. WG tried to create this with the pipeline approach by creating a filter system with some limited success. It would call a filter and then the data would come back, but that filter was actually a pipeline that you would send parameters to from your GUI. REST-based servers can also handle GET or POST HTTP requests to respond in an interactive manner for dynamic output. The issue is that this is highly interactive, but not much pipeline, non-interactive automatic processing happens here. This type of software requires a user actively doing things to process the data. So how to enhance, keep old-style non-interactive pipeline algorithms and add the ability of interactive? So the way we've done it in RAPIO is that there are two main threads. The first thread is a regular algorithm. It ingests data in real time or archive as normal, so it's the pipeline. You can output data if desired or not. It's no different than what you're used to right now in MRMS, HMN algorithms. The second thread is a REST-based web server that can process HTML commands and change the algorithm's behavior, report on algorithm state, and or use cached data history to do things on demand. To simplify the complications of thread locking, the web server commands are queued similarly to index record processing, and then they're processed by the main thread. So some of the use cases for this type of code, we can, for instance, we can generate map tiles on demand. We could do vertical slicing of data on demand, generate images on demand. Isosurface projection, you could actually generate pictures by passing parameters in real time. Charts and graphs, on-demand filtering or transforming of data. So let's say you want to turn off a color or change a color in your data, or you want to filter out things below a threshold. You can do these things on demand like you would with any GUI system, say like ArcGIS, for instance. On-demand data conversion, on-demand statistics, or archive processing control. Imagine you have an archive algorithm that is processing 8 months of data. Well, normally you could start this algorithm, let it run for how many days it takes to run. If you had it running with the web server option, you could actually request a web page update that showed you how far it was along in the archive, or maybe it has statistics, max and min, or something, whatever you want it for that algorithm while it's running. You might even be able to send it commands like tell the algorithm to pause or restart. Okay, so now I want to show a tile server example. And right now I am on a Windows machine and I've brought a terminal and I've logged into a Linux machine. You could run these things on the same machine, but I'm just showing it that you can be different machines. So I'm in the web example folder in RAPIO, and I've got some scripts here and I've got a couple data files. One data file is just a CONUS image from this 2021. This is an example of a lat long grid. And the other one is a May, I think it's May 3rd, 99 KTLX data set in our internal NetCDF format that we have. So if I look at, I'm going to run the CONUS debug. It'll let me. And you'll notice here I've installed the software in this particular location, but RTile, and my input file is this CONUS file. I have an output, which is called cache, real-time, and web 8080, and I've got FlySQL box. This FlySQL box is just a fly guy added that will put outlines around the tiles, because that way when you see it, you'll kind of understand more about what's going on. So if I run this code now, you'll see a bunch of, it's basically an algorithm, just like any other algorithm, but now it's paused. And it's still rating for real-time data. If I was ingesting from a FAM source, it would get files updated in real time from that FAM source. But in this particular case, I'm doing it as a one-shot file. So I'm reading that one file. And there is no more data to process. So it's just waiting with the data it has. So what I'm going to do is I'm going to go to this. This is a web page that I have on my Windows machine. And this page, basically, I have written a Leaflet TMS, Openlayers TMS, and a Leaflet WMS. Because what our tile does is that it waits for REST requests from this. So when I click on this, you'll see what happens is immediately I'm getting tiles being generated by that algorithm running on the Linux machine. And you'll see down here at the bottom, you'll see the, if you go down, oh, my cursor's not showing, but if you go down to the bottom, you can see that it's saying TMS tile XYZ. So this bottling box is my debug mode, just showing the tile. So as you zoom in, for instance, if I go into here, you'll notice I can zoom in, and this server is actually responding to reverse tile generation dynamically. And this is a standard protocol. So I could, if I view source, let me see if it'll let me do this. View page source. In this leaflet, in Leaflet for TMS, you basically, I think you just pass the address. TMS, you got ZXY. This is a format for TMS, tile map server tiles, the format of it. So this is what it's passing to the Linux server. And Google Slippy tiles are regular. You can swap this Y, or negative Y. Sometimes you'll get upside down tiles depending on which order you're expecting. But that's TMS. If I go to Openlayers, Openlayers also does the same thing. So it'll let me do this. But this is the same thing with Openlayers. And then there's another type of file where you've got straight bounding box style. This is more, ArcGIS uses this and some other, but WMS is a little different. It passes in the actual coordinates of the box. So you can see the same, but it's the same thing. I didn't print out XYZ in this case because I didn't have the XYZ, but it's passing in. But you can see the coordinates in the bottom are a little different on the bottom line. I think those are actually spherical Mercator box coordinates, which then get converted to lat long grid. And then you march in the projection space, and then you have to go back and convert. You have to actually project twice, and then you project back into your data. It's a little complicated how you do it to actually get your data out of the data set, but when it's all said and done, it's pretty quick, and the server can tile. So the idea with this is that I've got the basic RTile, and the RTile backend program responds to the HTTP requests. But I would probably, to expand upon this idea, I would probably need people that are front-end coders, that's, for instance, that know how to make React components, for instance, to make, for instance, a control system similar to WG where there's time controls up and down. Then when you pass parameters to the backend server, you would also pass time, product, and it could work as a backend server that way. So that would be a project that could be kind of cool to do if you had front-end programmers to work with me while I worked on the back end to make the back end more powerful. Actually, before I go to the end, let me show one more thing. Let's go back to the this original server, I'm going to stop it. And I'm going to run, there's one here that says run KTLX.sh. And it's using that KTLX. So we're going to run that one. And we'll go back to the server terminal. And this time, I'm going to click on Leaflet again. And this time, we don't have a CONUS. Aha, there we go. Some of you may recognize this particular data set. This is actually directly from our NetCDF. So, but you'll notice even with this, as you zoom in, you get more and more detail. I mean, obviously, you go past the resolution of the data here. There would be nothing to prevent you from increasing the parameters on the server to do things like toggle colors or change colors. What I will show you real quick, one last thing, is that in the server, I will go back into the configuration. I have color maps. So basically the reflectivity, I've got the reflectivity color map in this directory. And I also have the merge reflectivity composite, which was what the first CONUS was. So you need to have the color map for your data. Otherwise, that's how it converts the color. So it's a standard woodsy color map for how it actually generates the tiles. I think that wraps it up. So I'll end with the thing, where to get it. GitHub, http, github.com, RE2Me RAPIO. The clone command, you can obviously pull it. If you want to run as a container, you cd RAPIO container and run the build script there. It'll actually build you a full Docker. It's a development Docker. I've covered it in other videos. And that's it. Thanks for watching.